See, I will explain this question. So, this is a door which is supported by hinges. Door will be supported by supports, which we call them as hinges. So, mass of this door is 50 kg, height is 4 meters, width of this one is 2 meters. And this is the position of the hinges. Clear? Now, magnitude of each force exerted by hinges is equal. It means the force exerted by this hinge and this hinge on this door, it is equal. Then I want to calculate what is the magnitude of force exerted by each hinge on this door. Okay? Come on. So, this door is in rest position, no? It means again it is in two types of equilibrium. Translational equilibrium is also present. Rotational equilibrium is also present. So, based on that, you just do this problem. Clear? For example, for this door, weight will be acting exactly at its center of mass, no? So, this is the weight, which is 50 into 10 is equals to 500 Newton. Okay? So, because of this weight, this door tries to come down. But why it is not coming? Hinges are supporting, no? So, if weight of this door is acting downwards, then force exerted by the hinges should be in opposite direction. Then only translational equilibrium will be existing. That's all, no? And how many hinges are there? 2 hinges are there, and what is the data he gave? Force exerted by each hinge will be equal. It means this hinge will bear a weight of 250 Newton. This will bear a weight of 250 Newton. That's all, no? So, if I take first hinge, this will give an upward force of 250 Newton. And downwards hinge also, it will give a force of 250 Newton. And therefore, the condition of translational equilibrium will be satisfied. Understand? But what about rotational equilibrium? So, is a torque exerted by this weight on these knobs or on these hinges or not? How? Because force is not acting on the axis, no? This is the axis of rotation. Along this axis, this door will rotate. Are you able to understand? So, this force is acting at some perpendicular distance, this much distance. So, if this is 2 meters, this distance will be 1 meter, no? So, from the axis at a distance of 1 meter, this force is acting. It means definitely torque is applied by the weight of the door on the hinges. Can I say, ma? But if torque is applied, why door is not rotating? Are you able to understand? This door, definitely it is exerting some torque, no? What is the magnitude of its torque? R dash cross F dash. Clear, no? So, radius is so much from the axis of rotation. Distance is 1 meter. And what is the force applied? 500 Newton. So, because of this torque, door should rotate in this direction, in anti-clockwise direction. Why it is not rotating? Hinges may be providing torque exactly in opposite direction. That's all, no? So, this torque and torque provided by these hinges, when they get balanced, then a condition of rotational equilibrium also exists. That's all, no? Therefore, how can I write equation for rotational equilibrium? How can I write? Total torque should be equal to 0. That's all, no? So, at which point shall we take torque equation? Here we can take, here we can take, here we can take. Here if you take, then you have to measure torques due to this one and this one, both of them. But if I take torque at any point, here if I take the axis, then torque due to this hinge will become 0, no? Are you able to understand, ma? If I take this as my axis of rotation, then force exerted by this bottom hinge, torque due to this force will become 0 because it is acting on the axis itself. So, I will take my point either here or here. I will take, for example, here. Clear? Now, how can I calculate? So, torque due to door, positive or negative? Positive torque, no? So, plus 500, distance is how much? 1. 1 into 500. That's all, no? Now, what about torque due to this hinge or torque due to this hinge on this axis of rotation? So this hinge is also giving rotation here, no? Okay, only two forces are existing. One is weight of this door, another one is torque given by the second hinge on the first hinge. That is where we have taken the axis of rotation. Are you able to understand? So this hinge should give force in which direction such that this torque due to weight of the door is cancelled. Opposite means what should be the direction of force? Force direction should be in which direction?
Upwards.
If it is downwards, then it is passing through the axis, no?
Upwards, sir.
If it is upwards, then also that force is passing through the axis, no? Perpendicular means in this direction or in this direction?
This direction.
In this direction. Why?
Anti-clockwise.
So this is this type of torque, no? Positive torque. So this hinge should give negative torque. Are you able to understand, ma? So what is this distance from this hinge? This distance is, this is 1 meter, this is 1 meter, total 4 meters, no? So this distance will be 2 meters. That's all, no? And this hinge should give force in this direction. Okay? So this is the force given by first hinge. Okay? So R dash cross F dash. This is R dash cross F dash. So this torque and this torque will get cancelled. Are you able to understand? So therefore, how can I write minus of, what is the distance between these two hinges? 2 meters. 2 into, and what is the force exerted with that hinge? I don't know. So let it be F1. That's all, no? So 500 by 2 is equals to how much? F1 is equals to 250 Newton. So I got both the forces, no? So the upward force is 250 Newton. Horizontal force is also 250 Newton. Then what is the total force exerted by this hinge? 250 root 2, no? So total force is equals to square root of 250 square plus 250 square. So nothing but 250 root 2 newtons. That is my answer. This is the total force exerted. No, total force means vector quantity. Definitely we have to take the resultant. So if this hinge is exerting this much force, then what is the force exerted by this hinge? Same. That's the condition he gave, no? So magnitude of each force exerted by hinge is equal. So this is also exerting 250 root 2. This is also exerting 250 root 2 Newton force on this door. Are you able to understand, ma? Okay. For example, instead of taking axis here, if I have taken here, previously I have taken here, no? If I take my axis here, then on this axis, on this hinge, force is exerted by this hinge in which direction? In this direction. That's all, no? Because if this hinge exerts force in this direction only, then only R dash cross F dash, it will give opposite torque. Are you able to understand? So this hinge is pulling the door in this direction. This hinge is pushing the door in this direction. That is the effect of these two hinges. Are you able to understand? For example, if I have taken my axis here, then what should be the direction of force exerted by this hinge? So this is positive torque, no? This hinge should give negative torque. Therefore, what should be my direction? R dash cross F dash. How I have to rotate my hand? Like this, huh? How I have to rotate? I have to rotate like this. This is R dash cross F dash, negative torque. Okay? So this hinge is pulling the door. This hinge is pushing the door with equal force. Are you able to understand? So this is how hinges will behave for a door. Okay? Make a note of this. Dear students, now let us see this question. A thin uniform rod AB of mass m is equals to 1 kg moves translationally with an acceleration a is equals to 2 meter per second square due to two anti-parallel forces F1 and F2. So let it be a rod where it is given that forces are applied like this. This is F1 and this is F2. So they are anti-parallel, acting exactly in opposite direction, and distance between them is given as 20 centimeter. So this is the distance. And also given this F2 is equals to 5 Newton, therefore we are supposed to find out the length of this total rod. So also it is given that acceleration is 2 meters per second square. So if I know acceleration and mass of this rod, then I can calculate the net force which is acting on this rod. So F net is equals to mass into acceleration. So F net is equals to mass of this rod is 1 kg, acceleration is 2. So 2 Newton is the net force which is acting on this rod. Now the question is, if this is 5 Newton, then F1 should be either 7 Newton or 3 Newton. Then only in this condition the net force will become 2 Newton. So here if I write here the force acting is 7 Newton, then from the center, as this is a bigger force, torque due to F1 should be greater when torque compared to F2. Definitely the rod will rotate, but it is given that the rod is moving only translationally. So definitely I can say Phi2 should be a bigger force when compared to F1. So therefore if F2 is equals to 5 Newton, then F1 should be equal to 3 Newton. So these are the two forces which are acting. Now the question is, what is the orientation of this rod? Whether this rod is moving like this or whether this rod is moving like this. This information still we don't have. So what I do is I will try to calculate the sum of torques by taking center as my axis of rotation. Because if I take here as is my axis of rotation, then one component of mg also, it will show some torque at the edge of this rod. But I don't know this rod is moving at what angle. So I will consider taking the sum of all these torques at the center of mass of this rod. Because mg is acting at the center of mass only, and at the center of mass mg cannot show any torque. So therefore taking torque, taking sum of torques at the center of rod, I can write down that. So if F1 is providing anti-clockwise torque, then F2 should provide clockwise torque, and both of them should be equal. So therefore, and from the axis of rotation, F1 is at a distance of L by 2. If I take this total rod to be L, so therefore I can write F1 into L by 2 should be equal to, now what about this distance? F2 is present at this distance from this axis of rotation. Or in terms of L by 2 and 20 centimeter also I can write. F2 is present at a distance of total L by 2 minus a distance of 20 centimeter, then it will give only this distance. So therefore I can write F2 into L by 2 minus 20 centimeter. So F1 value already we have calculated, 3 into L by 2 is equals to, F2 is 5 into L by 2 minus 20. So therefore 3L by 2 is equals to 5L minus 100, or we will write separately. So 5L by, we will write like this, 5L by 2 minus 100. So therefore 5L by 2 minus 3L by 2 is equal to 100. So therefore 2L by 2 is L is equals to 100 centimeter. So therefore length of this rod is equals to 1 meter. That is our answer. Dear students, now let us see this question. So a uniform ladder of weight W and length L is resting between rough floor and smooth vertical wall. The ladder makes an angle of 53 degrees with the horizontal. A man of weight 3W climbs the ladder and stays at a distance of L by 3 as shown in the figure. Find the ladder's normal reaction and friction at its base. Find the minimum coefficient of static friction needed to prevent a slipping at the base. This is the question. So let us see how we can draw the diagram of this question. For example, this is a smooth vertical wall. So this vertical wall is smooth here, coefficient of friction is 0, and this is a rough horizontal surface, and a ladder is resting like this. Okay, so here there is some coefficient of friction which is acting. Weight of this ladder W will be acting exactly at the center of mass of this rod W, and a man of 3W, he is climbing this ladder and he is staying at a distance of L by 3. So if I consider this distance to be my L by 3, so here a person is standing, so therefore his weight 3W will be acting downwards, and this distance is given as L by 3. So these are the two forces which are acting downwards. Now what are the other forces which are acting? So if I call this as a smooth surface, then this smooth surface will give only a normal reaction here, so let it be N1. And here this ground is a rough surface, so this ladder tends to slide here, so therefore friction starts developing in this direction, and normal reaction will be acting exactly in upwards direction, so let it be N2. Now here the rod is in both translational equilibrium and rotational equilibrium also. So if I take the forces which are acting parallelly, and that is downwards and in horizontal direction, vertical forces and horizontal forces, then here I can see that 3W and W, they are downwards, and N2 is upwards in this condition. So therefore I can write N2 is equals to 3W by W, which is equals to 4W. So let it be my equation number 1. Now if I study about horizontal forces, N1 and F, these are the only two horizontal forces, and because as the rod is in translational equilibrium, definitely I can say N1 and F should be equal. So therefore I will write N1 is equals to F, and let it be my equation number 2. Now actually if I calculate the coefficient of friction, I want mu s into N2, so whose value we doesn't know in this condition. So therefore I will use the concept of rotational equilibrium also around any point. So which is the axis I have to select, so that I can get a minimum number of forces. Then the point is definitely this point, which is at the end of this rod, because if I take axis here, then torque due to friction will be 0, and torque due to this N2 also will be 0. Now I have torque due to 3 forces. There are torque due to N1, torque due to W, and torque due to 3W acting at this point. So therefore these two are downward forces, and this is another force. So torque due to W and 3W should be cancelled by torque due to N1. Because of W and 3W, torque is in this direction, torque is present inside the plane of this page, or we can call this torque as clockwise torque, and torque due to N1 is anti-clockwise, so both the torques, they will get cancelled. So therefore I can equate them directly. So 3W, it is present at a distance of L by 3 cos 53, because this angle is given as 53 degrees here. So if I redraw this diagram here, then force is acting in this direction, 3W, and this length is L by 3 here, and if this is 53 degrees, then this is L by 3 cos 53. So therefore the torque due to 3W, I can write it as L by 3 cos 53 into 3W, so length into force, 3W. And now if I consider torque due to this W, so this W is again at a distance of L by 2, but if I take this component, which is the perpendicular distance from the axis of rotation, then again it will be L by 2 cos 53. So plus L by 2 cos 53 into, now the force of weight of this rod is nothing but W. So these two torques should be balanced by N1, which is at a perpendicular distance of L sin 53. So this is total length of the rod, this becomes L sin 53, this is L cos 53. So it is at a perpendicular distance from the axis of L sin 53. So N1 into L sin 53. So these are my values. So if I substitute, if I see the calculations here, so L and L gets cancelled, 3 and 3 gets cancelled. So now I have cos 53. Cos 53 is 3 by 5 into W plus cos 53 into W divided by 2 is equals to N1 into sin 53 value is 4 by 5 here. So here we forgot substituting 3 by 5, so let us write. So 3 by 5, 5 here 3, 5 here 5 also gets cancelled. So 3W plus cos 53 is 3 by 5, already 5 is cancelled. So 3 by 2 into W is equals to N1 into 4. So therefore N1 into 4 is equals to, if I take addition of these two, so this is 6 plus 3, 9 W divided by 2. So therefore N1 is equals to 9W divided by 4 2s are 8. So this is N1 value. So N1 is friction, already we have calculated here. So therefore 9W by 8 is equals to mu s into, and this friction is because of this normal reaction N2, whose value is already we have calculated is equals to 4W. So mu s into N2. So therefore 9W by 8 should be equal to mu s into N2 value here is 4W. So therefore W and W gets cancelled. So mu s is equals to 9 by 8 4s are 32. So this is the minimum coefficient of friction required so that this rod does not. So now let us see this question. A ladder has negligible mass and rests on a frictionless floor. The crossbar connects the two legs of the ladder at the middle. The angle between the two legs is 60 degrees. A person sitting on the ladder has a mass of 80 kg. Find the contact forces exerted by the floor on each leg and tension in the crossbar. So what is the normal force that is exerted by the floor on the leg, and what is the tension in this crossbar that we are supposed to find out. So therefore, if I draw the free body diagram of this given question, then I can draw like this. So friction acting is absent in this condition because this is a frictionless floor, and here a man is sitting. It means that here a total weight of 800 newtons is acting. So here there will be a normal reaction of N1, here there will be a normal reaction of N2, and here there will be a tension of T, and here also there will be a tension of T. So these are the different forces which are acting, and definitely I can say, if I equate this horizontal forces and vertical forces, then if I take this horizontal forces, definitely I can say N1 should be equal to N2 because of the symmetry of this figure. And N1 and N2, if they are equal to N, then I can say 2N should bear this total force of 800 Newton. So therefore N is equals to 400 Newton. Now if I draw each side separately, then this is how I can draw. Then here a normal reaction of 400 Newton is acting, and then I can say here a force of 400 Newton is acting, and because of this other side, so there will be a normal reaction of R also. So this side of the ladder pushes this side of the ladder with a force of R, and this side of the ladder pushes the other side of the ladder with the same force of R here. So, and also at the center there will be a tension of T here. So one normal reaction already we have calculated, contact force exerted by force on each leg, so that is nothing but 400, and friction is absent here, therefore the only force which is acting is 400 by the floor on this ladder. Now there is one more question also which we are supposed to find out, that is tension in the crossbar. So to calculate tension in the crossbar, if I take torque, sum of all torque at any point, then we know that this ladder is in rotational equilibrium also. So therefore if I take the total torque acting at any point, then total torque acting should be equal to 0. Now which is that point which I have to select, so that very easily I can do this problem. So I will select this point, that is the top end of this ladder, because here if I take point here, then torque due to this 400 and torque due to this reaction between these two sides, so they will become 0 because they are acting at a distance of 0 from this axis which we have chosen. So therefore, now at this point only two forces are showing their torque. One is 400 Newton and another is tension. Now this angle is already given as 30 degrees. So if I draw this diagram again here, so this is the 400 Newton which is acting, and if this angle is 30 degrees, and if I draw this diagram like this angle should be 60 degrees, and if I take total length of this ladder is L, then I can split this one into two components. So this is L cos 60 and this is L sin 60. So already we have studied that if this is my axis of rotation, then perpendicular vectors only we are supposed to calculate torque. So that is, this is the force 400 Newton and this becomes the perpendicular distance from the axis of rotation, which is L cos 60. So one torque is 400 into L cos 60 because of a force of 400 Newton. Now similarly, on the same ladder there is one more force which is acting, which is called tension. Now I want to calculate a torque due to this tension again at this point. So if total length is L, definitely I can say this length is L by 2 because it is already given that crossbar is at a length of L by 2 in this condition. Now what is this angle? If this angle is 60 degrees, then I can split these vectors into, like this I will split them. So this is L by 2, this is L by 2 cos 60 if this angle is 60 degrees, and this is L by 2 sin 60. So this is the direction of tension and this is my axis of rotation. So from this axis, this force tension is at a perpendicular distance of L by 2 sin 60. So my second torque should be L by 2 sin 60 into the tension. So as the total ladder is in equilibrium, tau 1 and tau 2 both of them should become 0, or I can say that this torque is equals to this torque. So if I equate both of them, tau 1 is equals to tau 2, then I can write 400 into L cos 60 is equals to L by 2 sin 60 into T. So L and L gets cancelled. If I take this 2 to this side, then it will become 2. So 800 into cos 60 is 1 by 2 is equals to sin 60 is root 3 by 2 into T. So 2 and 2 gets cancelled. So therefore T is equals to 800 divided by root 3 Newton. That should be. Dear students, now let us see how we can do this problem. So a vertical force is applied tangentially to a uniform cylinder of weight W. The coefficient of friction between all the surfaces is 0.5. Find the minimum force F that can be applied that doesn't cause the cylinder to rotate. So what is the maximum force F that can apply so that this cylinder is just about to rotate? Now if I draw the free body diagram of this given diagram, then this is how I can draw the diagram. So this is the ground and this is the vertical wall to which this cylinder is touching. So therefore this is my force which I have to apply, and weight is acting downwards, W, and normal reaction N1 will be acting upwards, and this is normal reaction N2. Okay, so now if I apply force in this direction, then this cylinder will tend to rotate in this direction, in clockwise direction. Then here the direction of friction will be in opposite direction to the rotation. Similarly here also the direction of friction will be F2. And if the cylinder is about to rotate, then definitely I can say these frictions have already reached the maximum value. So therefore this is FL1 and this I can call it as FL2 because friction has already reached the maximum value. Now if I equate all the forces which along x-axis and y-axis, I can equate these forces because this cylinder is in equilibrium. So therefore along x-axis, so what are the forces which are in equilibrium? So along x-axis, FL1 and N2, only these two forces are present. So definitely FL1 should be balanced by N2 here. So therefore I will write FL1 is equals to N2. So let it be my equation number 1. Now writing equations along y-axis. Now along y-axis, what are the forces which are present? F, N1, FL2 and W. 1, 2, 3 forces are upward, 1 force is downward. So F plus N1 plus FL2 is equals to W. So let it be my equation number 2. Now here there are more than 2 unknown quantities, so I will have to take the help of one more equation. So I will take a torque equation about the center of mass. So about the center of mass, if I take the torque equation or sum of all the torques which are responsible for rotation, then sum of all torque should be 0, because this cylinder is about to rotate, still it has not rotated. So if I take this point as my axis of rotation, then torques due to this N1 and N2 will be 0, because their perpendicular distance from the axis of rotation is 0. So therefore this FL1 and this FL2, they are producing the torque. Now if I see torque due to F, then this is the radius vector R. So this is R dash cross F dash, negative torque. So minus R into F. And torque due to FL1 and FL2, they are positive torques, again which are a distance of R only. So R into FL1 plus R into FL2, totally it should be equal to 0. So therefore I can write F is equals to FL1 plus FL2. So here how can I write FL1 and FL2? FL1 is equals to mu s into N1. This limiting friction depends upon this normal reaction, and mu s values are 1 by 2, so N1 divided by 2. And FL2 is also equals to mu s into N2, because this limiting friction depends on this normal reaction, and mu value is again 1 by 2, so N2 divided by 2 in this condition. But there is one more relation between FL1 and N2, so that relation let us write here. So FL1 is equals to N2 and FL1 is equals to mu s into N1. So therefore N1 divided by 2. So therefore N2 is equals to N1 divided by 2. So this is one more relation I got. So let it be equation number 3. And let it be third equation, let it be fourth equation. Now if I substitute this N2 is equals to N1 by 2 in this relation, let us see what I will get. So F is equals to FL1 is nothing but N1 divided by 2. FL2 is nothing but N2 divided by 2. But N2 value is again N1 by 2. So therefore I can write F is equals to N1 by 2 plus 1 by 2 into, instead of N2 I can write N1 divided by 2. So F1 is equals to N1 by 2 plus N1 by 4. So which is equals to 2N1 plus N1, 3N1 divided by 4. So let it be my equation number 5. Now all these results I will try to substitute in this relation, because I want to calculate the force in terms of weight of this cylinder. So therefore F plus N1 plus FL2 can be written as mu s N2 is equals to W. So F plus N1 plus N2 by 2 is equals to W. So F plus N1 plus and 1 by 2 into, again N2 can be written as N1 by 2 in this condition. So therefore I can write N1 by 2 is equals to W. So F plus this is N1 by 4, so 5N1 divided by 4 is equals to W. So let it be my equation number 6. So now I got equation up to here. So I want F in terms of W, but here N1 is the unknown quantity. So already we have derived the relation between this F and N1, which is equals to F is equals to 3N1 by 4. Therefore N1 is equals to 4F by 3. So here I will substitute that one. So F plus 5 by 4 into, now instead of N1, I will substitute 4F divided by 3. So 4F divided by 3 is equals to W. So therefore, F if I take a common, then it is 1 plus 4 and 4 gets cancelled, 5 by 3 is equals to W. So F into 8 by 3 is equals to W. Therefore, F is equals to 3W divided by 8. So this is my answer. So required force is equals to 3 by 8 times of the weight of this cylinder. So this should be our